Well, hi, and welcome to my shop. Today is October 25th, and I was pretty much done with this radio. Very much done with it. If you watch the series, you know this ended on a bit of a sad note, this poor radio. I basically murdered the speaker in this radio. So it was quite a sick puppy to begin with, and my actions pretty much killed it. There you can kind of look through the grill and see something white in there. That's my band-aided speaker. So unfortunately, although the radio looks kind of nice, the cabinet's really great. With the speaker shot, what can you do? You'd have to get another radio just like this and hope to swap something back and forth and get something out of it. So unfortunately, I had to call up the owner of this radio and say, look, this is one of the few times where this hasn't worked out, and you can have your radio back. I don't. If things don't work out, I don't charge people any money. I don't charge people much money anyway for what I do. So he said, oh, well, guess what? I have another one. He had another one. Why didn't he give it to me to start with? Oh, well, look at this. Great cabinet, bad cabinet. All cracked, pieces missing. So, fantastic. Radio in here works? Don't know. Radio in here works except for the speaker. Let's compare what's in the back. So, I'm starting from scratch here. I'm looking in the back of this for the first time. So, what do we see? So, we see in this radio, there was a metal type tube here, and the clamps for gripping the shield that would go on the outside of a glass tube. They're bent out of bent. Look at this one. Here is the actual shield. That's really cool. Eh? It looks like almost like what would you call that? Armor. Armor. Okay. Anything else particularly different here? So on this radio, I broke the top of this adjusting can. This one sounded like kind of, it doesn't look already broken too. Broken from putting a screwdriver in and cranking it too hard. Okay, let's pull it out because I think it's ready to fall out, in fact. Yeah, there's nothing holding it in. The big question with this radio is, what condition is the speaker in? Here's the antenna. And the speaker's in the same cracked up condition. Of course, it's the same. Cracks all around. Doesn't mean it sounds terrible. Almost guarantees it though. Well, and has anybody been doing anything to this radio? Which I highly doubt. No, she's all original under there. What to do? Oh my gosh. You know what the best thing to do with this radio is? Plug it in and try it out right now. And give it a go. Let me just take another little look at it here before I do that. Nothing appears to be out of sorts under there. So the objective with plugging it in would be to find out what the speaker sounds like right away. This may not work out at all. Radio may just be a big hummer. Oh, wait a minute. Wait a minute. There's a nice, very, very flexible cord here. It's like a soldering iron strike there. A little bit of copper showing. This is what caught my eye though. So what's happened here is they've made a splice right in here, and the wire has been flexing here, right at the end of the tape. It's actually cracked the insulation, and there's the two conductors totally exposed. So yeah, I'm not plugging this in. Not like this, that's for sure. Well, I have to admit I'm a little disappointed to see the speaker like that, but not surprised. Generally speaking, all these radios are going to kind of deteriorate in the same sort of way. What am I going to do with this? So here, where the wire's been bent tight for a long time, it's cracked. Same sort of thing here. You can actually see copper right in there. The plastic has gone stiff. Maybe I don't know, maybe it's more than bending. So you can feel it almost get stiff right here. Copper showing right through there. Let's take a look at it right on the back of the radio. So a knot like this, of course, you know, is a real setup for cracking, but it hasn't cracked. Looking underneath, a rather scary thing done here. So, you know, this radio, the small radio, has a transformer, and these are the transformer leads. Looks okay. Looks okay for safe enough to use. If I could just get enough good wire here. Bit of a short power cord, and that's fine on my bench. Usually I'm talking up a storm, but I'm pretty quiet here. it took. Just going to make a connection here. I can't slide the shrink sleeve over. That's what's going to happen here. Solder very well at all. Shrink sleeve shrunk a little bit on that. Very hard to get it over now. Okay, you're supposed to shrink the sleeve after, not before. Just the copper sticking out right there. Okay, there we are. Now we're ready to plug this guy in and really get into trouble. Now, if you're new to my videos, I have a way of powering things on my bench that restricts the power. So if there's something really seriously wrong, all that happens is some lights come on bright. And the lights are those lights there. this outlet is powered through those lights when I want it to be done that way, which is the way I'm going to have it. So I can plug in now. There's no power here. Okay, switch is off here. So first thing we'll do, we'll apply power, and nothing should happen. There's no light in the light bulb socket. We'll find out if the switch really turns it off or not. So there's a couple of meters here in my shop that you can no doubt see. This one here is measuring the output of my isolation transformer, which is sitting right here. 100 and 115, 120, so it's 117 and a half. I don't believe that. And then I have this meter, which tells me the voltage at the outlet here. So if I interrupt the bench supply, you see no voltage there. And then this device, of course, really the coolest. This tells you the exact voltage at the outlet where this is plugged in, 122 volts. Not what this says. Okay, when I throw the switch on, what shouldn't happen is these lights become really bright. I'm going to take one bulb out of the circuit here, so it's just this light. If the light becomes really bright, and it's hard to judge on a video, then that means there's a short circuit in here. That would be very bad. The light should come on a little bit, maybe. Come on and then it'll go down. So it's going to come on and go down because there's current flowing, heavy current flowing initially through the tube heaters, but as soon as they warm up, that current goes down. You see that in the light bulb? Then once the tube heaters are heated up, the tubes themselves begin to conduct and more electricity flows in the radio. And you'll see that by the bulb coming up a little bit and becoming a little bit red. Now this is a really small radio, so you may not see any of this, which I just explained. Are you ready? Okay, so I'm not going to use the switch here. I'm going to turn the power off, turn the switch on. And my hand on the switch here for power in case something crazy happens. 3, 2, 1. So the crazy thing that's happened is nothing is happening. Take a look on here. 118. So this is lower now. Oh, here she comes. Something is happening. Okay, so I think that's enough for me to judge the quality of the speaker. So I hear a fairly nice hum, fairly well produced by the speaker, but I also hear it's hard to, the sound of air escaping through a small opening. That's what I'm hearing. Small openings are these cracks all the way around, and as the cone moves back and forth, air is pumped through these cracks, and you can hear that. It makes the paper maybe rub a little bit. I think if I just solve these cracks, this is just as bad as the other speaker. The cone does not appear to be, the voice coil does not appear to be rubbing in this radio. So I think if I can fix up this cone, we're in business. Then I'll simply take this radio, fix this radio up, stick it in the black cabinet, or in the brown cabinet. 2 thumbs up. The other alternative is to move the speaker from here onto that radio chassis. Why in heaven's name would I want to try to do that? Because I fixed up the radio here completely. It's ready to go. All I got to do is get the speaker fixed. And so if I were to switch the speaker, I'm done. And you run the risk of ending up with nothing at all in the end. I think it would be a little bit risky to move the speaker over there. Just working on the speaker is risky for damaging it more. It's already weak. I think the name of the game is fix this guy up too. There was something going on with this radio, I think. At the end, when I was just discovering the speaker was not going to make it, I was still thinking there was something wrong with the radio itself. That was would have to be sorted out. Maybe not the case with this one. Okay, so to get this guy going better, let's unplug him. Either I go ahead and do all those capacitors now, or do the hummers to get rid of the hum, or I try to fix the speaker right off the bat. If I can't make the speaker sound reasonably good, there's just no reason to do any more of this radio. That's the name of the game. The name of the game is make the speaker better. So we'll take a closer look at this speaker. It is crumbling. Oh my gosh. It's really, really crumbling. Let's see if I can do it with this camera here. No, I cannot. So let's try this one. Oh, it did focus, did it? I underestimated how bad the speaker was in the other radio. So basically the entire cone here is shot everywhere. And my normal practice would be to band-aid all these little cracks. Oh, look at that. This whole area here is... oh, I think maybe it's just a shadow. Yeah, it's just a shadow. It would look like you put any pressure on this piece of paper and it's just gonna tear away. Well, it works, we know that. The main part of the cone appears to be okay. It's all of this outer edge here. Yikes. Yeah, my usual solution is I don't think I can use it. You know what else I can see now? You can see it too. The shadowing in here. And the cone is misshapen. Those dark areas are that's shade. It's misshapen. Misshapen cone makes me think a chance of rubbing is much higher. Why does it look like the centerpieces, the dust cover has come off? I think it's just a illusion. Okay, she's in really bad shape. Among the worst again. Just like the other radio speaker, among the worst. Yeah, now that I'm looking at it, I can see it's all going up and down all through here. So, you know, another way to fix this is to get some kind of spray. Like you spray over the whole thing and make the whole thing seal up. And what have I got that would do that? So I don't have anything offhand, I don't think. Silicone spray? Would silicone spray do that? Do that job? Rubber, some kind of spray rubber cement of some sort would be good. Okay, so I rummaged around my house and I managed to find this product, Jamps Water Repellent. And I've read all the fine print on here. It promises to waterproof your shoes, and it says spray the seams with a little extra because that's where they're likely to leak. So those are strong suggestions, of course, that this thing will seal something up, this stuff. What is this stuff? Nowhere on this can or the other two products I have does it say what exactly is in here. So I'm not just going to start spraying it all over the speaker here. I want to experiment a little bit with it. So I do have a do have an old speaker to mess around with here, and I could care less what happens to it. Let's try that. I have to go outside and do some spraying with that stuff. Can't spray it in here. Oh, my one of my spare speakers here. Unfortunately, it took a bit. It was looking pretty good there a few days ago, but it is really shot. So, okay, I can't cry about damaging this one. So what I'm going to do, there's some spots here that are cracked similar to the speaker I'm interested in. I'm going to spray this area with this stuff. Find out what happens when you do that. Okay, so first shot at experimenting here. So I sprayed this part with champs. The question is, did it stick this at all together? It's just one. You know, I would think I'd have to spray it 4 or 5 times to build it up a bit. But let's see what happens so far. Not in the least. Not in the least. Is there any kind of adherence? Yeah, I don't think this can work. But I'm going to give it another try. We'll see what happens. Okay, so this is after multiple fairly heavy sprays, kind of soaking this with what comes out of that container, and you can hardly see the crack here now. Is it glued? Hope this stuff is dry. I don't think so. No. It's just zero adhesion. There's no gluing. There's no gluing taking place here. Should I try more? How's that ever going to help? I don't think I have the right stuff to fix this speaker. Well, you know what? I think I'm going to end up doing to this speaker exactly what I did to the other radio speaker. Patch these with some kind of fibrous paper and thin glue, and I'll probably just go all the way around the outside edge and just try to seal this whole thing up, because I don't think there's any damage internal here. It's all on the outside, except for the warping. Since the voice coil is not rubbing, maybe I can just do this and it's gonna be okay. Okay, there's my attempt there. Oh my god, this is a horror story. As soon as I started working on this speaker, I saw the cone was tearing away right on the very outside edge. Right where the outside of the cone is fixed, just under this ring here. So it just came away almost all the way around. Really bad shape. We'll see what happens. Again, you know, I'm not going to bet on this one. Okay, I think I'm ready now to find out what has happened to this speaker. Boy, I don't give this much hope. Not much hope. Okay, just neaten things up a little bit here. Okay, Mr. Speaker, what are you gonna do? So we're just going to let the hum do the work for us here. Here we go. 24. Yeah, not plugged in. Let's try it again. So I'm hoping for a nice sounding hum. No buzzing. Well, that's not bad. Okay, we don't need to let the radio run too long. Great. Okay, so I think the speaker's good enough to continue. It seems to have come around as opposed to what happened to the other radio. Great. So what I need to do is get rid of the hum next by augmenting the filter capacitor, which is right here. So I'm just going to try to install some capacitors down in here, and that should take care of the hum, and we'll see what we got at that point. Okay, just before I get going, I think it might be worthwhile to take a close look in the radio just before I start making changes. Excuse me, just in case there's something I really haven't noticed. And have you noticed in this shot there's something quite unusual in this radio? I'm really quite surprised to have found it in here. But let's take a look with the close-up camera. And so we're going to start up here with the capacitor. First thing I like to just look at how close this chassis ground terminal is to that terminal on the capacitor. Why, there's hardly a paper's width between them. Look at that. You know where I'm looking? Looking right up in here. There. That's a virtual short circuit there. This just went over a little bit. Wow. Okay. Anyway, at first I thought these must be connected. They're so close together. So when we look at the capacitor here, it's 3 terminals, and you can see they've soldered one of the twist lock type terminals for the outside of the metal can. Excuse me, right into the case here. They've soldered it in, and then they've used that as a ground terminal for these 2 capacitors. So there's 3 positive terminals on this capacitor. Excuse me. 2 of them will be for the power supply filter, a pi filter, and one of them is going to be for bypass. And it's pretty easy to guess which are which here, because 1 is green and 2 are brown. So the 2 that are brown are probably, almost certainly, the actual power supply filter, as opposed to bypass. Now if we just follow those brown wires, which I know are out of focus here. Oh my gosh. Well, I can't follow it. Trust me when I say, okay, this one we can follow. God, it disappears up in here. Oh, it's just, hang on 1 second. Here it is here. This is the brown wire. Disappears in the schmozzle. Over here, oh, you can actually get a look at it. You notice this fairly high wattage resistor, a low value, 222 resistor going into the schmozzle. The other terminal. Down there, and if I just swing around carefully to look down, that's the end of the brown wire down there. The other brown wire. So this is the pi resistor here. That's really what I want to say. Everything's making sense. So just by looking at these, I can figure out, you know, where I should put what size capacitor and voltage rating. Great. Now just go along through here and look everything over fairly carefully. Wow, that's really, that's a real pile of stuff down in there. Oh, it goes deep down here. There's caverns in this radio. It's a little odd that they left. It's not the neatest construction job here. I didn't trim that tail off from the capacitor there. Yeah, components are kind of, I don't want to say thoughtlessly put together here, but I mean, like with this wire coming up and over. Just looks like they should have prototyped this just maybe once or twice more. And now for something odd. That thing. Some of you will know right away what that is. But some of you won't, so I'm not going to say what it is right away. Just take a look at how it's constructed. So I have that white piece there with a wire wrapped around it. Clamped around it would be the right word. Can we see where that wire goes? It goes to the bottom. We see another white piece. So those two white pieces are springing together because they have a steel bar running between them, and they're squeezing on this flying saucer shape or funny hat shape with what's obviously rubber that's gone cracked. Okay. So that's a battery. That's an early battery. This would be similar in a sense to the battery that's in your computer. You have a battery in your computer keeping the clock up and other things very minimally when you turn your computer off. And now this wasn't doing that. Of course, there was nothing to keep on. This would be supplying some bias to one of the tubes. It's about a 1 volt deal, and essentially permanent, but not really permanent. Certainly not permanent to 2020, that's for sure. So this is a bit of a problem. Overcoming this, sometimes you just short it, just get rid of it, and short the leads together and carry on. Sometimes bias sometimes only critical when the signals get loud enough, and if you're just not going to ever play it super loud, you just get rid of that. But we'll have to check it out. Now, that was not in the other radio. There was not such a thing in the other radio. I guess you could call that a C battery. ABC. Everything else appears to be in pretty good shape. So if the radio doesn't work right off the bat, or works with terrible distortion, clippy sort of sounding distortion, it could be that battery right away. It could be the bad guy. Should also check that large wattage, this one here, this resistor. About done here. Well, surprising, something that can look this good after so many years, coming out of a radio that was really dirty with a cracked cabinet and everything. Okay. Well, it's now the 26th of October. This video is ranging over a few days, which is not my normal pattern. Usually I do a little work in the morning and post the video later in the afternoon, but this is going on over a couple of days just because of things. So this is the radio I've started working on with all the original capacitors in it. And this is the other similar radio. Both of them have a nameplate that says the same thing. R514. We're going to compare these. Now, unfortunately, because I've changed capacitors in this one, it doesn't look exactly the same as the other one. But it should be close enough. There's one thing in particular I am really curious about that I want to get a handle on. And just behind all this is a decision whether to which one of these two chassis to maintain. I can take the what may be a fairly good speaker now out of this radio and stick it in this one if I want, and I'm done because this radio's finished, or nearly so finished. Or I should fix up this chassis, leave the speaker where it is, not take the risk of moving it. There's definitely a risk to getting all these wires undone and reconnected and that. Leave it as is and bring this radio up to speed. This one, you know, along with the speaker, there seemed to me to be something else going on with it electronically. Not sure of that, but I just didn't get good feelings out of this one, even though I'd done all the capacitors in it. So what is it that seems to be so different? And it's right here, right where I'm pointing. There's a thing in here, and that thing is not in here. And what is that thing? That thing is a battery. There's a battery in this radio. One of those carbon button type batteries. I don't know if I can get it on camera easily. Let's see. See if I can pull this off. I think if you look from below, you can see it a little bit better. Yeah. There it is right there. There's a clip holding, it's basically, the battery is here, and there's a clip made of a C-shaped piece of steel wire and two, I don't know if you can see them, white porcelain contacts, I guess, and the steel is springy and it's pushing the contacts onto this saucer-shaped battery here, little battery. This is about a 1-volt battery, I think, when it's operating right. So these are common in older radios. A little surprised to find it in this radio. I'm really surprised because it's not in this one, and also it's not on the schematic. Not that I could see. Nowhere. So they both have the same model number, R514, yet this one has a battery and this one doesn't. So I'm wondering what other things are different here and what is going on. So what I'm doing is I'm snapping my eyes back and forth between these two radios, looking for anything that might be significantly different. Now, bearing in mind I have replaced capacitors. This one is this one. This one is this one. This one is this one. Where's this one? Okay. This one is, I think it's this one in this radio. I think they put a great big ceramic in here, and in this one they used a smaller non-ceramic capacitor. Unless it's hidden underneath. No, it's got to be this big guy. This big guy isn't sitting over here. Okay, so this one is this one. This one is this one. And that's the end of the road. Now I do see something different. The big high wattage resistor here is a 222 or 2200 ohms. Here's its brother, smaller wattage, and it's brown, black. Oh no, this must be something else. Yeah, it's going somewhere else. Brown, black, green. Where's this guy? So it should be, well, it couldn't be that, could it? That's red, black, and I can't read the next band, but it's a small wattage. It's sitting right here, red, black, and green. It's sitting right here. This one, brown, black, green. Brown, black, green is sitting right here. Where's this one? Why is this one here? This is a field coil radio. Of course there's no, it is a field coil speaker in here, isn't it? I mean, that would be a dramatically different radio. So I'm looking at the speaker down there. Oh, son of a gun. You know what? This is not a field coil speaker. Oh, let me get it back here a little bit further. I think that's a permanent magnet speaker. Yeah. Huh. Wow. Okay, so that's a dramatic difference. Son of a gun. And there's no extension letter in the model number or anything. What are tricky people? What are they trying to do here? Huh. Yeah, I'm not saying anything. I'm just trying to figure out what's going on here. So, yeah. Everything else looks the same. Why they did away with the field coil and replaced it with this high wattage resistor sticking out here. Is that a later modification? No, it wouldn't be, would it? No, because once they put a field coil speaker in, they got to maintain the field coil current. So this would be the older radio, I would think. And as they progressed along in time, they did away with the field coil speaker. It's expensive. I think it's expensive to wind the field coil. And the permanent magnets, I don't know. I can guess away, I guess. I don't know. That's really odd. So what's the state of affairs here then? Well, that's right. These two brown wires coming from the filter capacitor get to either side of this resistor. Yeah. So field coil out, battery in. Now that's weird. You would think the later model they would do away with the battery. I mean, these batteries operate only so long, probably intended to operate for the life of the radio, just like the batteries in our computers. But you hang on to your computer or your radio long enough and that battery is not going to be working. That's supplying a very small bias to something. Probably, well, it's to this tube. Or is it to this tube? Appears to be involved with the first IF here. And the lead comes to a terminal here. And then it's capacitored into the radio, so there's no DC making it into there. It's disappearing up into the IF transformer. The other end of the battery wire goes to here, to this terminal. That has a little tiny resistor under here. By the way, in these old radios, when you see green colored wire, don't try moving it. My experience is green dyed wire insulation is as stiff as can be and just inevitably will crack right off. In fact, in a lot of radios, you find it self-cracking. Now, you probably can't see it in the camera, but I can see the check cracking all along this edge here. So this is ready to shed its insulation if you try moving it or anything. And then you got a bigger problem. Don't want a bigger problem. So one solution for these batteries is just to bypass them, just to short them, just put a wire right around them and do away with the bias. It doesn't sound like the greatest approach, does it? But for sure this battery's dead. Another thing you can do is you can re-wet these batteries, but the seal in them, there's a rubber seal in them, will have given out by this point, and they're going to stay wet for a while, a week, 2, a month, maybe. You'll get your 1 volt again, but it's going to fade away. I guess you could put a little pipe in here and have a little funnel, and every time you go to use the radio, put a few drops of water in the funnel down the pipe to your battery. In one radio, I have replaced these batteries with just modern batteries, and in that radio, I managed to actually fit right in the clip, more or less. Not going to happen with this one. So what am I supposed to do about this? It's not on the schematic. It's not in this chassis. This chassis is all fixed up. But as I mentioned before, it seemed to be something not quite right with it. Is there some way without, like, once I take the speakers off and commit myself to swapping them, if that's what I'm going to do, then that's a one-way trip. There's no coming back, and probably on the trip a lot of damage is going to happen. Wires are going to break, all kinds of stuff's going to happen on the way over here. Wait a minute, can't do it, I can't do it, I can't do it. There's a field coil that has to stay in this radio. There's no field coil coming from here. So I can't do it. I cannot swap these over. Wow, I'm glad I noticed that at this point. You know, like how do you find things? You just have no suspicion exists. I had no suspicion there's a battery in here. No suspicion that the speaker is a permanent magnet. What else is in here? No suspicion that the model number doesn't actually refer to the correct schematic. So my thinking was, okay, I'll fix the hum, get rid of the hum out, and see what we got. I think I still need to do that. So we'll put the time and the effort in to put in a few of these little capacitors here. 1, 2, 3 of them in there. Do the same thing over here. And just before I have a problem, making sure the power's off. I need to spread these terminals. They're just so, look, I can't even get the screwdriver in between them. They are so close. That's too tough, too hard to bend. There, that's better. Okay, now, should I leave this capacitor in and just augment it with new additional capacitance? I mean, the better choice is to cut it away, of course, but the problem with that is you lose the opportunity for some mechanical support when you're putting in the new parts. You get all these wires floating around. These are really... it feels like there might be a little bit of rubberiness in there. Well, it's much easier to just put the new capacitors right on these terminals, just as it is. Other approach is you go ahead and hook up to these terminals, get everything done, then cut the terminals afterwards. The fact is, if you cut these terminals, they aren't going anywhere anyway. The wires are going to hold them pretty much there. 3 capacitors in there. Okay, I'm going to do that. We'll see what we get out of this. I do like the puzzly side of this kind of work, that's for sure. So look at these 2 radios. This one's got the capacitor here. This is the one without the field coil. This is the one with the field coil. There it is right there. And look, of course there's no capacitor here. Wait a minute. Okay, another interesting difference in this radio. So this one, without the field coil, has this capacitor. It should not be loose like this. It shouldn't be able to do that. The one of the twist tabs underneath is soldered to the chassis, and that should make this really rigid. But look at the other radio. So the other radio had a different style of capacitor here locked into this bracket. So no bracket over here. But the interesting thing is the chassis is made to have a capacitor like this installed. So you'd think field coil, older, no need for tall capacitor. But you need a small capacitor, and that's what went in the bracket. So why this? You would think if this was the original radio and then later they switch to a permanent magnet speaker like in this radio, and then they get rid of the field coil, they need to introduce bigger capacitors in the filter and switch to just a simple pi resistance filter. They put a bigger capacitor in. wouldn't they have to cut the hole in here and make all the space? No, it's already been done. So what exactly is going on here, I can't sort out. It looks like this one's older. No, this one's older. No, this was the original. No, this was the original. I don't know. I just like the puzzly part of this sort of thing. So I'm still trying to pick what size capacitors I should install in here. Could be 47 microfarads, could be 20 microfarads, something like that. The challenge here is the capacitor that's in there, I cannot read the values from it. It's installed in such an angle that you can't get at and read the words on it. The schematic I have is for this radio with the field coil, whereas this one has the resistor instead. You know, the capacitors over here are fairly small, as they usually are in a radio with a field coil, because I think it's the field coil that's really beating the hum in these radios, in a field coil type speaker type radio. A resistor, no, it's not nearly as effective. So you're really relying on the capacitors. So the two capacitors need to be upped in size. So they certainly can't be 10 and 15 like here, over here. But if you put them in too big, that can cause some problems, especially on startup. So how big is too big? How big are these? And what about that resistor? Is this resistor any good? I should really check that. That's it. A little more than 2,000. $2,100. Color bars are 2,200, so that's fine. So all I have to do is just replace these now. There's an input and an output side around this resistor, and the rectifier tube feeds right into the input side of this. But a big capacitor there might have trouble with the rectifier tube on startup. How big is too big? Oh, questions. 50 might be too big. Now, the rectifier doesn't come on like that. The heater heats up and things start happening. So there's a bit of a time thing over which the charge current is spread. So the charging current is spread. Maybe I shouldn't worry that much about it. Okay, I'll make a decision. I will make one. You know, sometimes when I'm stuck making a decision, I look for some inspiration from something like the I Ching. Well, I don't have an I Ching. What I have is 1,000 logical laws. This is where I'm going to get my inspiration before I make my fateful capacitor decision here. Just because I'm going to randomly go like that. Oh, it's an interesting picture. We'll pick. Without reading them here. More randomness. Pick Lowry's Law. If it jams, force it. If it breaks, it needed replacing anyway. Okay, now that's a handy rule. I like that. Now I'm going to apply that to this. Okay, so I'm going to go ahead, I'm going to put in a fair size pair of capacitors here. I'm going to force them in there, and you know, if the rectifier flames out, so be it. Okay, last operation here. Cut the terminals off. Easier than you might think. Not so easy. I didn't really think about this till just now. There. Okay, I think I'm ready for a test. So once again, what we're still in the process of finding out is the speaker really any good? First with the switch off. Very good. Switch on. Watching the dim bulb here. Hoping it stays dim. Okay, everything looks good. Pretty quiet. That's a pretty quiet radio. Okay. Turn it up a little bit. String slips. String broke. That's okay. Not much in the way of reception. Okay, so what happens if I should touch the grid cap here? Down a bit. Don't have to touch it. Checking for heat in the tubes. Yeah. Okay. Well, that didn't give us much of a test of the speaker, but so far so good. Just wanted any kind of noise to come through. You know, any kind of noise, any kind of noise. Turn this back on. Any kind of noise. Sounds pretty good. That sounds pretty good to me. Good. Okay. So next step, probably test the tubes in here. And carry on with the capacitor replacement. Thanks for watching so far.